Hello everyone, I'm Ryan Lodi and I'll be presenting my project SpendSight, which provides AI utility bill analytics. I worked on this project alone and I'm excited to share with you. So, like I mentioned, SpendSight is an AI-enabled bill extraction and analytics tool. The general flow here is that a user would upload a utility bill of theirs into the platform, and we'd use some sort of generative AI to extract the key fields and confidence score it. If there's a low confidence scoring, a human would review it, and then at the end of the day, they can use the platform to get presented analytics of the bills that they've uploaded to the platform. In terms of the components that I use for this project, I utilize Cloud Run to give us serverless deployment and auto scaling. I use this in our our UI, the API, and also the worker, which is responsible of talking to our AI extractor. I ended up using Vertex AI, the Gemini 2.5 Flash model, to do our extraction. It's multimodal, which is great. It wasn't actually what I initially wanted. I initially wanted to use a Google service called Document AI. They had a utility parser already included, and you wouldn't have to pay for the hosting of a custom parser and extractor. But unfortunately, they deprecated it as I started the project, so I used Vertex AI instead. It kind of made my own confidence extraction system. I went ahead and utilized PubSub as a message queue for our bill jobs. Cloud SQL is a relational database Postgres to store our bill and analytic information, which we serve in the UI. We use Redis for job status caching, Fast API for our worker and our API, as well as React for our UI, and then pretty importantly, cloud storage to store the images that our users are uploading. Okay, and so to highlight the interactions between all of these components, I'm presenting this architecture diagram. The user interfaces with the web UI from their browser, which allows them to connect to all of our services, which are enveloped in a VPC. The web UI talks solely to the API, which is responsible for accepting these file uploads. When a file is uploaded, we cache it in Redis and then publish the event in PubSub. That message is then consumed by our worker, which will then eventually extract fields. Those extracted fields are then written back to the database using Cloud SQL and then served back to the user on the web UI. And then also when they upload that bill, that's stored in cloud storage. The artifact registry here was just to serve the Docker builds and Docker images that we're using for our Cloud Run services. So in order to actually develop this application, I used a couple techniques for debugging and I actually learned a little bit too. I learned I probably shouldn't have developed the entire thing locally before testing it out in whole on GCP. Probably could have done it incrementally. Anyways, I used GCP cloud logging, and this was really great for the startup of our Cloud Run services. A lot of the issues I ran into were that the IAM roles that I were providing to the service accounts didn't have the exact specific role permissions that were needed, but instead just had like project-wide permissions in general. So I got a whole lot of permission denied. For example, like the API didn't have access to publish to the PubSub job or something else like that. For local development, I used PyTest and VTest. Unit testing was really helpful for me to make sure all of my applications worked that I was developing on their own, and then integrating them all together later. I could test that easily in the cloud. I used Docker Compose emulators. They had emulators for PubSub and GCS, so I was able to use that interface in my local development, which actually made debugging on the cloud easier. I ran into less issues, but also just gave me the same interface or similar interface. And then lastly, I used GCP Network Intelligence Center. I had some VPC issues, which I resolved actually just by creating a new Google Cloud project, but I used the Network Intelligence Center to help me figure out exactly what was going wrong. In terms of the major learnings, I think the biggest win was horizontal scaling, right? Using serverless architecture like Cloud Run would be really easy just to add more instances to our web and API. We wouldn't necessarily need it for the scale that we're going, but it's just good to know. In terms of one of the biggest bottlenecks, however, I find that the Vertex API was a huge constraint. Gemini has a really unforgiving regional rate limit. It isn't necessarily a quota, but if you send enough API calls to a specific region in a short amount of time, you'll get a resource denied error, 429. And that's something that I ran into pretty frequently when I tried spamming a whole bunch of builds. The best solution here would be to either do the entire extraction in-house or use a much more expensive service like Document AI. The other potential bottleneck that I found would be cache invalidation with Redis. If users were doing high concurrency uploads, there could potentially be some write contention or inconsistency in the scan and delete patterns in Redis. And finally, the biggest major learning, I decided to use Python scripts to develop and deploy all the GCP applications. And I think in retrospect, using some infrastructure as code platform like Terraform would help a lot. All right, hello everyone. This is past me who's going to be demoing the tool for the class project, which future me should have talked about in detail, explaining all the infrastructure and relationships and so forth. So I'm going to go ahead and sign in, and you can see the first thing I'm greeted with here is a dashboard, which shows some overall metrics for the last year. You have some information by provider, a review queue, which I'll talk about a bit more later. The review queue returns bill uploads, bill jobs that were flagged by the extractor with low confidence, which need human review. You can also see monthly spend, which for now is in April only, and recent bills, and you have the capability to upload a bill. While we're here, I'll go ahead and show off the analytics page. Here is where you get all the information from the bill extraction, and we present it to the user in the form of these pie charts, which shows spend by provider, spend by utility, and also a monthly spend trend. The user has the ability to filter down, so if I wanted to add, say, electric to the graph, I can go ahead and do so. You can see that my waste bill is exceptionally high on average. But yeah, I think the natural extension for this would be to attach some sort of LLM to get synthesized insights based on these analytics. For example, your electric bill is running a bit high. Maybe you should slow down your usage during peak hours, something like that. Anyways, let's go ahead and go back. I'm going to showcase the actual extraction process. We'll go ahead and upload this bill, a gas bill, and you can see here that the job started processing. So we'll go ahead and wait for our worker to process that and Vertex AI to extract all those fields for us. But in the meantime, I'll go ahead and showcase the bills table here. The bills table here is where the user sees all of the bills that they've uploaded alongside their information. The user has the ability to search by bill. They can filter and sort as well. And clicking on any of these rows here will navigate the user to a bill detail page, which will allow them to see side by side the extracted fields as well as the image, which we store in Google Cloud Storage. And I'll go ahead and show that off after this job gets done processing. Perfect. Okay, looks like it's done. So I'll go ahead and look for gas 4, which is our most recent gas bill that we've submitted. So you can see here, this is the result of the extraction that we just sent off. We have our bill on the right as well as all of the extraction information on the left, and you can verify yourself that most of it does match up correctly. The account number here matches with the account number in the image. Periods match up. Most importantly, let's just compare the amounts. 37, yep. Previous balance of 33.65, yep. Credits, yep, and so forth. So that kind of showcases the extraction process and then how it gets served back to the user. Let's go ahead and look at the review queue. I went ahead and purposely passed in the document that I made blurry. I used a Gaussian blur for this. Surprisingly, even though the blur was applied, Vertex AI Gemini was able to extract most of the fields correctly. They are low confidence, which makes sense, but surprisingly enough, it was able to process the information correctly. At this point, if I was the user, I would go ahead and verify with my bill on the right side that all of these numbers line up. And let's just say they do. I'll go ahead and click Save Changes, and you can see we're okay. Now, if I go back to the bills page, or sorry, the dashboard, you'll see our review queue is empty, and the bill that we had low confidence on has been reviewed. Okay, that showcases the tool and the general workflow. Thank you very much.